We're going to shift just a little bit to talking about margin of safety. And the margin of safety, the calculations will end up looking a whole lot like the break-even and the profitability calculations that we've done in the previous videos. They're just labeled something a little different and give you a slightly different result, but the math is basically the same. So what is the margin of safety? Well, there is hopefully budgeted or actual sales dollar that exceeds the break-even point. The difference between what a company has to sell in order to just break even and what it is truly budgeted to sell or is actually selling, that's the margin of safety. The margin of safety is how much a company can lose before it starts to lose money. In other words, how much sales can decline before it starts to no longer at least be profitable or break even, but venture into a loss. So it's the total budgeted or actual sales dollars minus the break-even sales. And so here we're going to illustrate this. We've got the Manteo Machine Company. I'm not going to sort of go through all of this, but it's safe to say that they've got a break even here in dollars of 153,000. So and this 1,900 units is what gets them to that. Their sales currently are at 2,500 units. So if we subtract what they would have to sell just to break even from what they're currently selling while they're profitable, this tells us that they can theoretically, their sales can decline by $72,001 or before they begin to start to report a loss. Now we can also look at this in terms of a desired margin of safety. And this looks a whole lot like the desired profit, because what really is our margin of safety? That's really our profit. That's the point over which we, our break-even point. So when we're looking at sales at margin of safety, it's our fixed costs plus desired margin of safety dollars, otherwise known as desired profit, and divided by the contribution margin ratio. We can also calculate this in terms of a margin of safety percentage, which is our margin of safety dollars, otherwise known as our operating profit, or what our profit, net income, and we divide that by our total budgeted or actual sales dollars, and this tells you the percentage of our margin of safety. So here we've got Marshall and Company, and they produce a single product. They calculate their break-even point in dollars at $11,000. What would Marshall's target margin of safety be in units and dollars if they required a $14,000 margin of safety? Well, so again, our fixed costs, $3,500. If we want the margin of safety to be 14,000, our numerator, and I can, well, so I threw a little text box in here. This is not going to be neat, but our numerator here would be our fixed costs plus, oops, told you it wasn't going to be neat, our target margin of safety, in this case, $14,000. And that's our numerator, over our contribution margin per unit, in which case is 175. Whoops, see, I told you this wasn't going to be neat. But that is our calculation in order to do that. We're going to move on now to talk about something called operating leverage. And operating leverage really talks about how sensitive the income is to the change in sales dollars. And what this really comes back to is what the composition of your sales dollars are between your fixed and your variable costs. Because if your fixed costs represent a significant portion of your product cost, well, those are fixed. So the more products you sell, that fixed cost isn't going to get bigger. And so at higher sales volumes, you're obviously going to have much larger profitability. On the other hand, if your fixed costs only represent a small portion and the bulk is your variable costs, then high sales, all that means is that your variable costs are going to go up precipitously with your sales volume. And so that is kind of the concept of operating leverage. So we got a scenario here. We're going to assume 10,000 units at $10 a unit, $100,000. We've got variable costs of $4 a piece, so 40,000. That leaves us with a contribution margin of 60,000. We have fixed costs of 25,000, which are more than easily covered, leaving us 35,000 left over. So what would happen in this case if 10,000 of the fixed costs were instead variable costs and variable costs were fixed costs? How would that change things? Well, in the beginning and at this volume, it doesn't make any difference. You're going to see this is the same income as it was before. However, as the sales volume increases, this scenario in terms of the bottom line changes. And so and we get a better result by changing the 10,000 of variable costs to fixed costs with a 10% sales increase than we do the other way around with that same 10% sales increase. Again, another example, and this sort of looks at the difference between, automation using machines to do a job that otherwise a human would do. And so this is a grocery store example that didn't have self-service checkout lanes, and this is one that did have self-service checkout lanes, both selling the same amount. Variable costs, however, are going to be lower with the self-service because they obviously have fewer employees that they need to have, giving them a greater contribution margin. On the other hand, their fixed costs are a little higher because they've got this machinery. So the company ultimately, though, that has the self-service lanes is going to ultimately be more profitable despite the identical initial sales. And so it's obviously getting late and I'm getting tired because I was easily distracted. But if you are curious about this little automation experiment and you want to see if a robot will take your job, all you have to do is go to willrobotstakemyjob.com and enter your job. But like I said, easily distractible the later it gets. An important number for a manager to know is what the company's degree of operating leverage is. So to calculate that, we've got the numerator as the contribution margin, the denominator as the net operating income. And so we'll compare these two. Company A, Company B. Company A has higher sales, lower variable costs, and higher contribution margin as a result, substantially higher fixed costs, and as a result, between the two of them, the net income turns out to be exactly the same. On the other hand, the operating leverage for both of these companies, despite identical net income, is very different. And it is because Company B has an higher fixed costs as a result, and that has resulted in a higher operating leverage than Company A. So if you want to see how operating leverage impacts net income, this is the formula for you. You take that degree of operating leverage, and then you multiply that by a percentage change in sales. And that's going to give you the percentage change in net operating income. And here's our example. Let me move myself here. And I just wanted to jump back to the original numbers here in our example before we look at how we're going to apply the changes. So you see company A 1.74, company B 2.47. Now let's look at what happens when we have a sales decrease of 20%, which ultimately will also result in a decrease of our variable costs by 20%. Company B, with the higher fixed costs, maintains the higher operating leverage. And as a result of this decrease, which again, they both experience the same proportional decrease, but now company B becomes less profitable as a result of its higher fixed costs. And so I'm going to sort of skip these. But basically, CVP analysis is particularly useful for managers, not only in terms of conducting break-even analysis, but probably most frequently in terms of deciding the product mix. Again, if you're doing a fruit basket, how many apples, how many bananas, how does that change your variable costs and thus your contribution margin, and then ultimately your net income. This can be applied not just in manufacturing or in a merchandising scenario, but certainly can also be applied in terms of service businesses as well. I won't sort of go through all of the summary because I think we pretty well covered it all. And that concludes Chapter 3.